Good evening, everyone. So we're going to finish off with Chapter 9. I just got 2 slides, really a couple of formulas I want you to see, and then we'll move on to Chapter 10. So to finish up Chapter 9, the cost of new common equity here. Pretty simple equation, but I want to walk you through it. We've got the dividends here plus the growth rate over top of the price minus the flotation cost. Right, that formula plus the growth rate, and we can see here that turns out to 13.6%. So that one, again, just a standard calculation that you guys should be able to do. Now, this last one for Chapter 9, I wanted to show you. So if we think about a 30-year debt at a par cost of $1,000, coupon value of 10% paid annually, we can go through all these different calculations and get to it. Get to that 6.15, but I want to show you this real quickly, how we would work that out. So let me bring my PowerPoint in here. All right, and it's just a rate calculation. I don't know if you can see as well up here, but I'll open it up like this. So we've got the number of the rate is the formula that we're using, or the function in Excel. We've got 30 for our number of payments. We got 60 for each payment. Present value is 980, future value is 1,000, and it gives us the answer of 6.15. I'm going to attach this Excel sheet to the announcement today because it's got quite a few formulas in it, and I think that'll be helpful for everyone for both Chapter 9 and 10. So if you don't catch it right away, you'll be able to go back and sort of put 2 and 2 together here. So, all right, so that's the end of Chapter 9. And let's jump over to Chapter 10. I'm going to try my best to go pretty quick on the first slides. There's a lot of formulas in the back half that I want to spend more of our time on. All right, so we're going to still looking at capital budgeting, evaluating cash flows. The overview, we're going to talk about some vocabulary, some methods, and that's where I want to focus. Net present value, IRR, MIR, which is modified, internal rate of return, and profitability index. And then we'll finish up with a few odds and ends. All right, so what is capital budgeting? We've been through this. It's an analysis of potential projects. It's a very long-term decision. This is not about, hey, do I go buy office supplies? These are capital decisions long-term, and it's very important to the firm's future. What are the steps? First, we want to know, hey, how much money is this going to bring in? What's it going to take from an outflow perspective as well? What are the risks to that cash flow? And then what is the rate for the weighted average cost of capital? And then we want to evaluate these cash flows. Why would we do such projects? What categories? So replacement to continue operations, replacement to reduce cost, expansion of products or market, expansion of a new product, contraction decisions, safety, mergers, or other. All right. So when we think about independent versus mutually exclusive projects, this is a big thing you want to remember. Independent means the cash flows of each of the projects are not affected by the other. And that won't, each project won't help you decide the other one. Mutually exclusive is the cash flows of one can be adversely impacted by the acceptance of the other. All right. And then you have some that are joint projects. They go together. So here's an example of some cash flows for 2 different projects that are exclusive. They don't tie to each other at all. We can see the outflow in basically year 0, right? To get started, it's the $100. In year 1, we're seeing $10. In year 2, 60, 80. This is for L, right? Project L, and a 10% rate on both, right? You can see the cash inflows are different for the second project, 70, 50, 20. How do we look at these? So, as usual, the book gives us a funky formula to start with. The net present value for these cash flows is the sum of all the present values of the cash flows. I'm going to jump right over this because I think you know what's coming up next. You can also figure it out on your line chart if you want to do the math, figure out the present values of those cash flows. It gives you the rate. It gives you everything you need to do that. You can also use standard, calculator, scientific calculator. The other thing you can do, bring in trusty Excel, use the net present value function. Simple. 10%. Here are our cash flows. 10, 6, 10, 60, 80. Right? So that gives us our dollar amount. And then at the end of the formula, you'll see here that I'm subtracting out the cost, that $100 that's in the end, at the beginning, excuse me. So I take the net present value of all our cash flow. I subtract out the initial cost. That gives me the $18.78 that they spent all that time working on the calculators and working it out by hand. We get to the same answer real quickly. So why would we use the net present value method? It gives us the present value of our inflows minus the cost. We just said that. It's the net gain in wealth. So if it's greater than 0, we would probably accept the project. If we're choosing between mutually exclusive projects, we want to look at the higher positive net present value because it's going to add more value. All right. Now, using the net present value, which franchise should be accepted? And when we're looking at S and L, right? Those two different examples we had earlier. So if they're mutually exclusive, accept S because it has a higher net present value. If they're independent, accept both. If they're dependent, net present value is dependent on the cost of capital. That is the biggest piece of the puzzle when you're doing a net present value calculation. The next one we're going to look at is internal rate of return, or IRR, as I've heard it called in the industry. It's the discount rate that forces present value inflows to equal cost. Okay. Just like a lot of things that you'll see and that you've probably seen in chapters past, it's not one calculation that's going to get you the answer, but it's the combination. So I don't want you to think about, oh, well, the net present value is one thing, so I'm going to go ahead and give my answer. A lot of times it could be the combination of NPR, IRR, MIRR, looking at all three together to give you the answer, especially in the real world. Not necessarily on a school assignment, but when you get out in the business world, we look at many different factors before we make a decision. We don't just use one calculation. So that's not in the book, but I just wanted to throw that out there. All right. So how can you figure out the internal rate of return? Again, you can use the present value of this cash flow to get to the number. You can see how they've done that here. But again, I'll have to X out here. But let's bring in Excel and do it quite quicker to get our percentage. When you're doing this, you're going to want to set it up correctly. You definitely have to have your initial outflow up top here and then your inflows below. And that's how this calculation works. You then just hit, and I'll just actually do it for you. So you hit equal IRR, you tab to get in the formula. You want to grab all these right here, close the parentheses, hit enter, and it gives us our 18%. Expand it out a little bit here. That gives us 18.13. We'll come back to Excel on slide 20. All right. So that's how you figure out IRR. What's the rationale behind using this method? So if the internal rate of return is greater than the going rate, then the project's rate of return is greater than its cost. Right? It's greater than the opportunity cost would be another way to look at it. Right? So a lot of times you're going to use that. When I was at a certain corporation, we had a specific internal rate of return that we had to hit before I could go forward with a project. Even if the net present value was great, I had to choose a project that had a certain IRR was actually 20% or higher, regardless of what the going rate was. So there are those hurdles sometimes. If S&L are independent, accept both IRRs because they're both greater than the rate. If they're mutually exclusive, accept S because it's greater. And then if well, again, on the third bullet point, IRR is not dependent on the cost of capital used. It uses other pieces of the puzzle to come up with this dynamic. So you may only have a number of dollars to use, so that may eliminate a project that has a better IRR at times. That's one way to look at that. All right, so when you're looking at some net present values, sometimes you want to chart them out to see where the crossover is. And this is how you want to set this up in Excel. That's just a quick way to see how to put it in chart form. And here's what you're going to be able to put out. There's Once you put the data in Excel, you just tell it to insert a line chart, and it'll show you, and then you can see real easily where these lines cross, and that's going to be your crossover point. So if you're asked to pull that out of the data, it should be pretty easy to do. So why do we have why do the net present values cross on two different projects? It's real simple, and I'm not going to get into all the words here, but each project has different size, and they have different timing, right? The funds come and go at different timing. Those are the two biggest things, right? Is the size and the timing difference. The last, well, not the last one, but the next we're going to talk about is the modified internal rate of return. So it's the discount rate that causes the present value of a project's terminal value to equal the present value of cost. So you're basically compounding inflows at the weighted average cost of capital. This sounds really complicated and difficult, but it's not. So let's look at the example. So again, I set up my outgoing dollars and inflows, and instead of doing IRR, I just do MIRR. Right? And that function is a little bit different. You do your values first, so I'm going to grab all of those. Then I'm going to put the financing rate and the reinvesting rate, and in this situation they're both 10%. Hit enter, and that tells me the modified internal rate of return is 16.5% compared to the standard internal rate of return, which was 18.13%. Okay, so we're starting to put the pieces of the puzzle together. So now we're going to quickly talk about profitability index. It's the present value of future cash inflows divided by that initial cost. In other words, bang for a buck. How much are we getting out of each dollar that we're investing? So the one way that they show you how to do that is using a standard, the line chart here. So we'll show you how to do that as well. Excel. Same thing, I've got my dollars here. In this instance, you have a positive on the 100. That's one thing that's different. But you simply do a net present value calculation. You put the rate, and you're just doing the inflows of the dollars there. All right. So first you have to figure that out. And then you divide that amount, that's your net present value of your inflows. You're going to divide that by your cost, which is the $100. To get a positive amount, you leave that positive. That's the only difference. To $1.19, and we'll see that on the next slide. So instead of going through all this, using all this line chart to get to the 118, and then this other writing it out, we can do that all in Excel in two quick formulas and get to the $1.19. Pretty simple stuff. I love Excel if you haven't noticed in my class. Alright, so what is the payback period? The payback period is the number of years required to cover the cost of a project. Or how long does it take for us to break even? Line charts are probably the best for doing this. We can see pretty easily our cash flow, and then the cumulative is just going to be adding it up over the years. It's not going to give us this 2.4, so we know between years 2 and 3 that we're going to break even at some point. But we know that we only need $50 out of that 80 to get there. So we take the 80 and we're going to divide it by the 30, and that's going to get us that 3.72.375. Okay, pretty simple. Alright, same thing here. We're looking at the second example. How long did it take? It took 1.6 years. So strengths and weaknesses of using the payback period. It provides an indication of the risk and liquidity. It's easy to understand, easy to calculate. Some of the weaknesses, it ignores some of the total value. And it ignores cash flows occurring after the payback period. So it's a little bit limited. You can also do the same thing using discounted cash flows. Basically just doing the present value of the cash flows and then finding that break-even point. Alright, so we'll have to come back and finish up the last 13 or so slides on the next presentation to finish up Chapter 10. Thanks, guys.